Hello and welcome to my first lesson in a series of lessons on the topic of differentiation. In this lesson, I want to tackle definition of differentiation and derivative of polynomial, but in subsequent videos, I'm going to take you through equation of a straight of a tangent and normals, stationary points, curve sketching, application of differentiation to kinematics, application of maximum and minimum. And therefore, let's just begin with the first thing, definition. As a define, I want to say that to differentiate really means to find gradient at a point. That could be gradient of a curve or a straight line. So to differentiate means to find the gradient at a point. We're aware that gradient of a straight line is just the same all through the line, but gradient of a curve, it keeps changing, and therefore the gradient at a point, to obtain that, would need to differentiate. I can also say that differentiating a function gives gradient. That's just what this statement really implies here. When you differentiate a function, we are looking for the gradient. A function is a formula of some kind, and you look at examples of those. Say, for example, we have y is equals to 2x plus 4. To differentiate these would mean we will obtain the gradient of this, and we know that the gradient of this line is 2. To differentiate this other one here, y is equals to minus 7x would give us a gradient which is minus 7. What about y is equals to x squared? What would we get if we differentiate this? To differentiate this, we need the more concepts than what is already familiar at the point where a student is assumed to be when they're doing this topic on differentiation. And therefore, this is what really this topic is dedicated to, and so I'll take you through how to do that in a short while. Let me say this: when we have a line y is equals to 2x plus 4, and you want to differentiate this, we will be obtaining the gradient, and at this point we are familiar with the following process. We might need to plot the line as it is there, obtain the change in y, again change in x, divide the 2 to get the gradient, and the answer should be 2. To take you through that is, we have 2 points of the line. The point is 0, 4. We have another point 4, 12. If we want to find the gradient, we take the change in y over change in x. Now clearly the change in y here is 12 minus 4. That means the line, the point we picked, the 2 points we picked, the change between the 2 points along the y-axis is 12 minus 4 units. How? This point here, the y value is 4. At this point here, the y value is 12. So the change in y, this displacement here, is the same as this displacement, which is just 12 minus 4. Similarly, the displacement along the x-axis would be, we get the x value here and the x value here, subtract this minus this value here, and we get the change in x-axis. All right? And therefore, the answer is 12 minus 4 and 4 minus 0. The answer is 8 over 4, which is 2. The gradient is 2. Let me say that if we have a line y is equals to minus 7x, we don't have the y-intercept. So this line passes to the origin. Now, to obtain the gradient, therefore, we could probably draw the line as it is indicated there, obtain the change in y, obtain the change in x. The change in y in our case is, we have the 2 points, the origin and another point here, the point negative 2, 14. The gradient is negative. That means it's sloping this particular way. And so the change in y would be 14 minus 0. Why? The y value here is 0. The y value at this point is 14. So we'll have 14 minus 0. So the change in y over change in x will have 14 minus 0. The numerator, that's the change in x, would be, how does it change from here to this point? It moves negative 2 steps. How? We have negative 2 minus 1. Minus 0, sorry. The x value here was 0. The x value here was negative 2. So we have negative 2 minus 0, which is negative 2, and we have 14 divided by negative 2. The answer is 7, negative 7 in that matter. And therefore, we have obtained the answer we would have anticipated. What about y is equals to x squared? What about it? We are going to notice that this line, this is a curve, which when plotted would be quadratic as what you have on the graph there, all right? And therefore, the gradient of this is not easy to point out, as we have pointed out in the previous 2 cases. You see, even before we operated the questions, we knew that the gradient of y is equals to x plus 2 is 2. Y is equals to minus 7, the gradient was negative 7. We knew that, but this one, we cannot just point out by looking at the question. And that's what this topic really is dedicated to. However, for the sake of explaining that further, let me say this. The gradient of this one here keeps fluctuating. It's a function. It's not a number like -7 or 2. And again, if we take 4 points, say these points that we have on your screen there, and we try to establish the gradient of those points, we are going to draw tangents to the curve at every point. Look at the gradient of that tangent, and that will be the gradient of a curve at that particular point, as we said at the very beginning. For example, we can draw a tangent through the first point and obtain the gradient. That will be the gradient of a curve at that particular point. We can do the same for the other point there. We can do the same for this other point. We can do the same for that other point. However, the answers we get, they are all of them different. That substantiates my claim. The gradient fluctuates. I'll show you, therefore, what's the function for the gradient. But for the sake of this lesson, or at this point, let me say that the gradient, I know it's 2x. We will be proving how is it 2x in a short while. Take this as the question, y is equals to minus a third. What is the gradient of this? Obviously, the gradient is 0. We have the line is a horizontal line. If we take 2 points, this point, this other point, the point here is 0, negative a third. This one, the point is 4, negative a third. So the change in y is, there is no change in y because y is remaining negative a third all through. It doesn't matter where you are in the line. So the change in y will be negative a third minus negative a third. The answer is 0. But the change in x is from 0 up to 4. So we have 4 minus 0, which is 4. Therefore, the answer is 0 minus 0 divided by 4, which is 0. And therefore, we have the gradient is 0. What about if the line was, say, x is equals to 2? If you had a vertical line passing through this way, what would be the gradient? The gradient would be change in y by change in x. The y values would be changing, but x value are not changing. X is remaining constantly 2. So this particular part would have a number for the numerator. For the denominator, would have a 0 because we'd have 0 minus. We'd have 2 minus 2. Whatever two points we pick, would have all of them. Every time the x value will be 2. So we'll have 2 minus 2, which is 0. Whatever number we get for the numerator, therefore, it doesn't matter. We're going to have a number divided by 0, which is infinite or undefined. That tells you the gradient of a vertical line is undefined, but the gradient of a horizontal line is 0. Why? We don't have any slopeness or steepness. There's no degree of slopeness, or I would say there's 0 degree of slopeness for that particular line. Allow me to use that kind of language. Therefore, that gives us the gradient is 0. But for a vertical line, the gradient is undefined. Let's pull this far. Generally, therefore, when we are given a line, a function, y is equals to x raised to power n, when we say we're differentiating, we are looking for the gradient, and therefore we're looking for change in y over change in x. That one is synonymous to dy divided by dx. It's also represented by y prime. Master those notations, they're important. But y is equals to x raised to power n. To differentiate that, that is, it means we multiply every term. Sorry, this term, everything in that, this particular term, we multiply it with n. So we have n times everything. But the power of x reduces by 1 from n minus 1. So it's n minus 1. Therefore, this is the differentiated answer for the differentiation of y is equals to x raised to power n. Similarly, if we have an m here, so we have y is equals to m x raised to power n, we'll do the same thing, only that this time around we have an m, so it still remains there. So it will be n, this n times everything, but the power of x reduces from n by 1 to n minus 1. And therefore, the answer is that on there. What we have obtained here, and also what we have obtained here, is what we call derivative of y. And therefore, we say we are differentiating y with respect to x. These are important for us to master the definition of differentiation. What we are doing here is we are looking for the derivative of y, and having looked for it, we can also say we are differentiating y with respect to x. Remember, the y values of y could change, x could change, could be s in terms of t or p in terms of r or whatever. Let's look at examples. First one is y is equals to negative a third. How can we do that? First of all, let's appreciate the fact that y is equals to negative a third is the same as y is equals to negative a third x raised to power 0. Since in indices, anything raised to power 0 is equals to 1, therefore we have x raised to power 0, which is 1. So 1 times this is that. So this function is this. So to differentiate using these two rules I've explained here, it's going to be close to what we have for the second one, all that m is negative a third and n is 0. So we're going to have changing y by changing the x equals to 0 times, I put everything else in brackets, only that the power of x I've reduced from 0 to 0 minus negative 1, which is, so 0 minus 1, which is negative 1. So it is 0 times anything. And please understand this. Anything we multiply 0 with 0 in mathematics gives us a 0. That gives us a constant rule. Whenever we're differentiating a constant, the answer is always 0. That's constantly 0 because we are looking for gradient of a line which doesn't have a gradient, a horizontal line. Similarly, we go to the second question, y is equals to 2x plus 4. Differentiating that again, I say we get the power of x here is 1. So 1 times everything else in that particular time, we have 2x. But the power of x reduces from 1 by 1 to 1 minus 1, which is 0. The second time, the power of x here is 0. So it's 4x raised to power 0. We have 0 times everything else. But the power of x reduces from 0 by 1 to negative 1. So we have it that way. So the first term will have 1 times 2 x raised to power 1 minus 1. 1 minus 1 is 0, so x raised to power 0 is 1. So we have 1 times 2 times 1, which is 1, which is 2. The other one, anything multiplied by 0 is 0. Therefore, this reduces 0. And therefore, the derivative of y in this case will be 2. Let's go to the next one. We have y is equals to x raised to power 5. How do you operate this? This is essentially like the first case here. We said we would multiply everything by 5 and reduce the power of x by 1 from 5 to 4. Therefore, changing y of changing x will be 5x raised to power 5 minus 1, which is 5x raised to power 4. Please master that. It's very, very important. What about when you have y is equals to x raised to power 11 over 5? We do the same thing. We'll have changing y over changing x is the same as 11 over 5. 11 over 5 multiply everything else, and then we have x in brackets 11 over 5 minus 1, which is we'd have 11 over 5 x raised to power 6 over 5, and I think that's clear. Another question, we have x is equals to y is equals to x raised to power third, so it'll be 1 over 3 x raised to power 1 over 3 minus 1. Therefore, we'd have a third x raised to power negative 2 over 3, and that's that. Please slow the video so that you can always follow the things that I'm mentioning there. Now, for polynomials. Polynomials are equations which have many terms. A simplified one would be this one here. Y is equals to 2x plus 4. This is a polynomial. When you're differentiating polynomials, we differentiate every term separately. An example, we have y is equals to x raised to power 4 minus 4x cubed plus a half x squared. Differentiate every term separately using the rules that I mentioned at the beginning there. So we have 4 times x raised to power 3, because the power of x being 4 reduces by 1 to 3. So we have 4x raised to power negative 4x raised to power 3. We have negative 4x cubed. This will have 3 times negative 4x raised to power. The 3 reduces from 3 to 1 by 1 to 2. So it'll be minus 12x squared. The other one is a half x squared. We have 2 times half times x raised to power 2 minus 1, which is 1, and therefore we have just x. And that's it there. Differentiating this one is just differentiating every term separately and just putting them, considering their signs. And another one, we have s is equals to 9t raised to power 5 plus t cubed minus 3t minus half. And therefore, this follows the same rule. Please understand that this is now a change in s with respect to t. Differentiating s with respect to t, or derivative of s or s prime, or change delta s over delta t, and that's it. And follow the rule again. Differentiate every term separately. We're going to have 5 times 9 t raised to power 4, which is 45t raised to power 4. This other one will be 3t squared. Hey, this is supposed to be positive. That was a mistake there. And then the other one will be minus 3. And I think that's that. Hey, let's turn over to the last part. And let me say this. We can have questions which are not as straightforward as those ones, and therefore I have 3 examples that I want us to look at. And let's begin with this one. We have y is equal to x squared plus 4x plus 4 divided by x plus 2, and there's a quotient there, there's a fraction of sort. Therefore, I should say this. Since this question is not easy to operate as it is, at least for this level, there's quotient rule, product rule, and many other rules, which are not for this particular level. For this particular level, therefore, a student is supposed to transform this one to ensure that the question appears as a normal polynomial. And that means, first of all, realize the numerator is a perfect square, x plus 2 times itself. The denominator remains the same way it is, so we can cancel out. Just divide that way, you get this function here reduces to y is equals to x plus 2. Differentiate the way we have done in the previous examples. It will be changing y or changing x will be 1. And I think that's simple. If the question is, say, what we have here, y is equals to root x in brackets 2 x raised to power 2 over 3 minus x raised to half, we do a similar thing. That is, let's make it a polynomial and then operate. So this time round, we'll expand using the rules of indices. Please understand root x is the same as x raised to power half. So x raised to power half, multiply with everything in the bracket and get x raised to power 7 over 6 minus x raised to power 1. Differentiate using the same rules we've done in the previous case. So the first term will be 7 over 6 x raised to power a sixth minus 1. And I think that's simple. The idea here is make it a normal polynomial and start operating. The next and last question, with y is equals to x squared plus x, all of that multiplied by x raised to power negative 2 minus plus 1 divided by x squared. And therefore, we operate this way. Expand the numerator. And as you expand that, please follow the rules of multiplication of brackets. That is quadratic expansions. And you'll get something like this: x raised to power 0 plus x squared plus x raised to power negative 1 plus x. And the denominator is the same way it was. Again, this time around, I've just written this again because I think a student might need to know that x to the power 0 again is 1. Take care of that. Divide everything by x squared. Divide all through by x squared. What will be the answer? It will be that one there. Okay. Again, follow the rules of indices, and then we differentiate. Let me take you through step by step every time in this case here, before I even give you the answer. The first term is x raised to power negative 2. So following the rules of differentiation, it will be minus 2x raised to power negative 2 minus 1. So the first term will be minus 2x raised to power negative 3. The second term, differentiating a constant is 0, so we don't even need to think about that. It's at 0. We don't even need to have it a feature there. The third term was x raised to power negative 3. So it will be negative 3x raised to power negative 3 minus 1, which is negative 3x raised to power negative 4. So notice that this term it becomes negative. This term also turns to be negative again. What about the last? We have x raised to power negative 1, so it will be negative 1x raised to power negative x raised to power negative 1 minus 1, which is negative 2. So it will be negative x raised to power negative 2. And I think that's simple. And that's what we have. So we had 4 terms. One of them goes away. We remain with 3. And all terms become negative because the negative indices. And I think that's it for the first lesson, an introductory lesson to differentiation. I hope you find it helpful. Please check out next 2 or 3 days. You'll get a video for the next thing, equation of normal and the tangent to the curve.